What's up everyone, and welcome back to our new tutorial series on NumPy. So first thing we're going to cover, why would you want to use NumPy? So first thing, what is NumPy? According to their definition, it's a fundamental package for scientific computing in Python. And so what that means in plain English is it's going to let us do a bunch of linear algebra. It's going to let us manipulate large arrays of data so that we can do all kinds of different operations on them. So if we want to do linear algebra with them, like if we want to do matrix multiplication, or if we want to resize arrays or something like that, like if we want our 3x2 array to become a 2x3, or to take the transpose, or to do any other kind of number of operations you might have learned in linear algebra class or some other sort of higher level mathematics class, you can do it in NumPy. A lot of these things you can code in normal Python just with lists and stuff like that, but you're going to be writing a lot more code and you're going to be doing it much less efficiently because NumPy actually uses compiled C for a lot of the different operations. And so what we're going to do is we will just hop over to Sublime, and what I'm going to be doing is I will show off just some samples of what we can do with NumPy. So first thing, if you don't have NumPy, go to your command prompt and then just do pip install NumPy, and that should be all you need. So just start off with that, pip install NumPy. It might ask you to say yes or no on whether you want to install it, but it should be pretty simple. So first thing we're going to do with the actual code is let's just make a list to start off with. I'll show how we can do something with a list and how we can do something with NumPy. This is just going to be a basic little sampler. If you aren't totally familiar with the code, don't worry about it. We're going to be covering all of this later. I just want to give a little sample of what NumPy can do and how it really helps us in making our code simpler and also speeds things up. So what I've done here is I made list A is equal to 1, 2, 3, list B is equal to 1, 2, 3. And so how would we go about adding list A and list B? So let's say we want to add 1 to 1, 2 to 2, 3 to 3. Well, the normal way we would probably do this is we would make a third list, and let's just make it an empty list. And then what we'll do is we'll do for A val, B val, and zip list A, list B, list C dot append A val plus B val. And so this might not be exactly what you would do, but something along those lines. You're probably using a for loop in order to get all of them correctly indexed and added together. So what this is doing is we're combining our list A and list B using the zip function, and then we're iterating through it with the for loop, and we're grabbing the first item is our A val, second item is our B val, and then we are adding them together and we're appending that to our new list, and that's going to output what we want. So let's let that run, and then we will print list C. And so we go ahead and we get what we're expecting. We get 2, 4, 6. That's all we wanted. And so now what we're going to do is we'll show how you can do that in NumPy. So I'm going to import NumPy as MP. This is the idiomatic way to do it. That's what everyone does. You import NumPy as MP, and then you're going to do all of your operations as like np.add or np.dot if you're doing dot multiplication. But let's just create an array A, numpy.array 1, 2, 3. And so we're doing exactly what we did before, where we're creating, in this one it was a list, but in this one we're doing a NumPy array, because that's kind of their equivalent data structure. So then we're going to do numpy.array 1, 2, 3. And then in the previous one we had to do this for loop, and so we went through the whole process of going, okay, we're going to do this, then this, then this. And in this one all we have to do, let's just print a plus, or let's do it like the last one where we did c equals a plus b, and then we'll print c. And so you can see we got exactly the same thing. It's in additional brackets from the other one, but that's just how the arrays work if you want the correct dimensions to be passed through. We'll talk more about dimensions later, but for now let's just gloss over that. So that's pretty good. That means that instead of writing all of this code, we get to just do a plus b. So that's pretty simple. But the additional thing is we gain a lot of speed from that. If you have some math that you'd like to do, you can measure the time and you can compare them, and you'll find that this is significantly faster. It's like 10 times faster. So if you're doing large operations where instead of just having a 1 by 3, you have a 50,000 by 50 or something like that, and you're multiplying it together with something else, it's going to be so much faster than a for loop that it's just unbelievable. You need to use NumPy, because the for loop is going to be so slow that it's going to waste all your time. And so on top of that, what if we want to do something like a two-dimensional array? So right now it's just like a vector where we just have 1, 2, 3. But what if we want something like that, where we have two separate columns? So what this would look like is it would be something like that. Let me separate this out so it's a bit more clear. So you've got your 1, 2, 3, 1, 2, 3, and so we've got 2 rows and 3 columns. And so if we wanted to do this with a list, this would actually be more difficult, because we'd probably have to do even another for loop. So we'd have a for loop within a for loop, and we'd have to make sure all of our indexes are correct and all of the other stuff is lined up. But if we want to do that with NumPy, I'm just going to copy and paste this so I can do it faster. Then we can do a plus b, no problem, and you can see it got both of those correct. So we're doing 1 plus 1, 2 plus 2, 3 plus 3, and so on for this second row. And so we didn't have to do any additional for loops. It's way faster and way simpler to code. And so you just have to format your stuff as NumPy arrays, and you're good to go. This is just a sampler, so if you're not following this, I'm just trying to speed through and give you some examples. In the future, we're going to be covering everything piece by piece. We're going to talk about indexing, we're going to talk about dimensions, we're going to talk about shape and size, and we'll do some matrix multiplication, and we'll cover all of that. But for now, I just want to show the benefits of NumPy in this little simple example. But for today, that's going to be it. Thank you for watching.